Okay, we should all have our notes packets out. Make sure you write down what I write down. Pay attention, focus, that sort of thing. If you need to pause it or rewind it or ask questions, have Miss Allen pause it and maybe she can explain, do a better job than I do. Probably. Okay, today we're talking about inscribed angles. Our objectives: find a measure of an inscribed angle and find the measure of an angle formed by a tangent and a chord. Remember, a tangent is a line that touches our circle in only one spot. A chord is the inside line of a circle, goes from one end to another. It doesn't have to go all the way across. It could just take up like a third of the circle, not just like a diameter. So tangent outside the circle, chord inside the circle. Okay. So we have this thing called an intercepted arc and an inscribed angle. Well, what an arc is, arcs are always on the outside of our circles. They're part of our circle. And an angles are on the inside. So this angle right here makes up this arc. So I kind of think about it like if I bring this angle out, it makes up that arc. Okay? This little theorem down here says the measure of an inscribed angle is half the measure of its intercepted arc. Okay? So what I like to think about, we'll go back up here, is that if I have, it says pretend the measure of AC, so that'd be this arc, is 90, and you're bringing in an inscribed angle. So you're bringing this in. Well, if you bring it in, you're going to half it. Okay? So if I half 90, or divide by 2, so times by half divide by 2, that angle is 45 degrees. Okay? I think technically they want half of 90, that's 45. Okay? It also works the opposite way. If I have the degree measure of an inscribed angle, so all the way inside of my circle, if I have this measure, let's say it's 60, should use this one, JK's, 60, when I bring it out, well, if I halved it when I brought it in, to bring it out, I'm going to times by 2. Okay, so bring it in, half, bring it out times by 2. So 2 times my measure, which is 60, is 120 degrees. So this measure of this arc right here is 120 because it's double 60. Okay, we'll do some more examples. It says in circle O, what is the measure of angle A? Well, you have to look at what angle A makes up. So angle A goes from here to here. Okay? Well, you gotta look at the arc associated with it. Okay, so the arc goes from here to here. So it's like wherever your angle leaves off on your circle, that's the arc that's associated with it. Well, you'll notice that they have this line to the middle. That line is called a diameter. So you don't even really need to see angle A to know that this arc is half a circle. And so half a circle is 180 degrees. Circles are 360, so half that would be 180. Okay? Well, if I need to find angle A, this angle, I'm going to bring the arc in. So I'm going to take half of 180, and that is a 90-degree angle. This next one wants me to find all the different angles. So let's start with angle A. Angle A goes from here to here. So the arc associated with it is this arc right here. Well, I know that to bring it in, I gotta take half, so I'm going to do half of 100 plus 90, because that's what it takes to match up with my red angle markings. So angle A, 95 degrees. That is just calculator work. Half of 190, 95. Angle B. Angle B goes from here to here. So the arc associated with it is that guy. Again, since we're bringing arcs in, we're going to take half. So half of that 90 plus 64 is 77 degrees. Angle C. We'll go here. Angle C. Arc that makes it up. Half of 106 plus 64 is 85. And I ran out of room, so we're just going to find angle B. Okay. Says, what do you notice about the sums of the measures of the opposite angles in the quadrilateral in part B? Well, we didn't do B, so not these two, but these two. Angle A and angle C. What do you notice about them? Well, 95 and 85, they're not the same, but they add up to 180. So they are supplementary. Exciting stuff, kids. Alright, we gotta find the measure of angle A. Well, A goes like this. So I know that the arc associated with that is labeled as 84. So to bring it in, I have to half it. Half of 84 is 42. So that's angle A. Okay? And you'll notice, when I do angle B, it intercepts that exact same arc. So let's take a wild guess about what angle A and angle B have to be. The same. I could do that math again, but no matter how many times I do the math, it's the same answer. Okay, the next up we have are our fun theorems, corollaries, all that good stuff that you can refer back to. This corollary 1 is at the exact same thing we just looked at. If two angles intercept the same arcs, if I have that angle and this angle, but they intersect the exact same arc, right? That's the same for both of them because they end up in the same spots on our circle. Then those two angles have to be the same. Okay? This one we looked at back in that first example we did. If an angle inscribed as a right angle, then this has to be our semicircle because it's halfway through. Well, because 90 times 2 is 180, and 180 makes up a semicircle. So that kind of makes sense too. And then this last one we looked at, opposite angles of quadrilateral are supplementary. So these two add up to 180. So B plus B equals 180. And the other A plus C equals 180. Same sort of stuff. Okay. This little infographic is beautiful. I'm not going to talk about it. You can read it if you want to. Next theorem says the measure of an angle formed by a tangent. So remember, tangent is a line that comes through and touches our circle in one spot. Okay. So the measure of an angle formed by a tangent and a chord, remember a chord is just anything that touches two ends of a circle, is half the measure of the intercepted arc. So that literally looks like what we just did. So if I have this arc, to find this angle, I'm just going to half it. Okay? Kind of what we just did. Or I might be crazy, maybe that's not what we just did. I don't know. Okay, these should be pretty quick, pretty simple. If I have this angle 24 and I'm bringing it out to its intercepted arc, Bring it out, you gotta times by 2. 24 times 2, 48. Boom. Next one, I got this angle. When I bring it out, oh, I lied. When I bring it out, I double it. The thing that's labeled though, sorry, is the arc. So when I bring the arc in, it gets smaller. Bring it in like you think about suck it in, or like suck it out, I don't know. They suck it in, it gets smaller, so we gotta take half of the 88. I don't know, what else you got to memorize that? Bring it out times 2, bring it in times 2. I don't know, maybe it's just simple. I don't know, up to you. Okay, I got this angle A that's intersected by this arc. Well, I don't have that green arc, so I gotta find it. Well, I know things about circles, and one of the things I know about circles is that when I go all the way around, I make 360. Well, so I have this is 90, this is 96, the only chunk I'm missing is that green, so I can figure it out. So I have 360 minus 90 minus 96 leaves me with 174. So this green arc has to be 174. And then I gotta bring it in to find my angle. Bring it in, which means I gotta half it. Half of 174 is 87. Oh, here we go. That's the answer. Okay, here's where we start getting a little more complicado. That's complicated for you kids that don't know. Finding angles. The only thing, well, not the only thing, but the thing I want to work with is this arc right here, 56. Well, you notice that this angle A makes up that arc. So if I bring that 56 in, I can take half of 56 and realize that A is 28. So I got it. Okay. To find B. Only other thing that's labeled here is this 94. Funny thing, angle B makes up the intercept arc. So if I take half, let's do that up here. Half of that 94 gives me 47, which is that angle B. And the last one, excuse me. If I take 180, so I gotta find this angle, right? Which is also vertical to this little triangle. So I can find the triangle. You're okay. Triangles that up to 180. So if I subtract the two angles that I just found, I can find angle C. Angle C is not an inscribed angle, so you can't do the math that we've been doing. It just doesn't work like that. Okay. Quadrilaterals, that thing we just had. Quadrilaterals, opposites are supplementary. So those gotta be supplementary. So to find A is not bad. We gotta take 180 minus that 98. And A is 2 degrees. That's that little corollary. The last one. Left, right. Right. On the right. Okay. To find, what should we find next? How about B? To find this arc, you need to find an angle that is inscribed by it. But there is no angle that goes from here to here. Does not exist. So we gotta manipulate some of these dealios. I do know that this is 34, so that's helpful. What about, do I have an angle that goes from the blue and green combined? Oh, looky, I do. And I know that this is 82. So So if I bring this 82 out, it'll be the total of these. Okay? So if I bring that 82 out, 82 times 2, 164, but I gotta subtract out this 34, because that's not B. B is 130. And we'll shoot Marcy for right now. But I am running out of room real quick. Alright. This guy is 200. This angle is inscribed. So when we bring this in, we got half 200. So this guy is 100. Let's write that down real quick. You got a triangle. Triangle's up to 180. I got 140 so far, so A has to be 40. Try the rest by yourselves, and I will have Miss Allen post the answers. Do your homework and behave.